Hello everyone, myself Dr. Suresh, Professor of Biochemistry, and in this video we'll study about the specialized products that are synthesizing from tryptophan and its related disorders. So as we have already learned from the catabolism part of tryptophan that it has got two metabolic fates, like one is 𝗠𝐞 pathway, other is NADPase pathway. So here the other specialized products are forming, so one we have already covered, that is vitamin B3 synthesis, and the next thing is serotonin synthesis, the hormone which is synthesizing from tryptophan. So we'll see how it is synthesizing. Tryptophan first converted to 5-hydroxytryptophan, 5-HT. Okay, so here what is happening, molecular oxygen is involved and converted to water molecule by the enzyme hydroxylase. So here hydroxyl group is adding here. Okay, so that's why tryptophan converted to, at fifth carbon of benzene ring there is addition of hydroxyl group, so tryptophan converted to 5-hydroxytryptophan. So tryptophan hydroxylase will work with the help of the coenzyme tetrahydrobiopterin and convert it to dihydrobiopterin. Here you see the donor of again regeneration of dihydrobiopterin by NADPH, which converted to NADP. So if there is any problem here, tryptophan hydroxylase will not work and there is no formation of serotonin. Okay, so remember of this. So 5-hydroxytryptophan further converted to 5-hydroxytryptamine. That means there is a first hydroxylation, addition of hydroxyl group, and second step there is a removal of carboxylic group. So okay, addition and removal. So addition of what? Hydroxyl group, deletion of what? Carboxyl group. And this aromatic amino acid decarboxylase is PLP dependent. Okay, so that's the reason vitamin B6 is major contributor in amino acid metabolism. So most of the reactions in amino acid metabolisms are taking place with the help of vitamin B6. If B6 is deficient, your protein metabolism is going to be hampered. So you have to take care of your diet, which has to be rich with pyridoxal phosphate, that means B6. So here aromatic amino acid decarboxylase removes the carboxylic group from 5-hydroxytryptophan, it converted to 5-hydroxytryptamine. So the chemical name of serotonin is 5-hydroxytryptamine. Tryptamine, okay, the amine form which is serotonin. Now this is in link, like as I told you, the specialized products not only niacin, it also synthesizing serotonin and again melatonin. So from serotonin again melatonin formation is there. We see here from serotonin the degradative pathway like monoamino oxidase, which convert into 5-hydroxyindoleacetic acid, which is excreted product of serotonin and also tryptophan. Otherwise it enters into melatonin pathway, which convert into acetyl serotonin. That means here 5-hydroxytryptamine converted to acetyl form, that is acetyl serotonin. The donor of acetyl group is acetyl-CoA, and acetyl group added to serotonin and to convert acetyl serotonin by the enzyme acetylase. And again there is a requirement of melatonin formation methyl group addition. So the SAM, acetylmethionine, is the donor to this. So SAM is converted into SAH after donating its methyl group by methyl transferase. So acetyl serotonin now forms melatonin. So this way serotonin and melatonin are synthesizing from tryptophan. First hydroxylation reaction, second decarboxylation reaction, and step 3 monoamino oxidase enzyme system, which converts 5-hydroxytryptamine to 5-hydroxyindoleacetic acid, which is excreted product of serotonin. And step 4 you can say there is acetylation, addition of acetyl group to serotonin to form acetyl serotonin. Again there is addition of methyl group with the help of SAM to form melatonin. So 5-hydroxytryptamine, tryptamine. Okay, what are the advantages you see here? Monoamine, it is a single monoamine substance, it is a neurotransmitter. It produced in brain basophils and mast cells, platelets of GIT mucosa. In brain, bound serotonin reserpine and decreases serotonin level, calming and depression. So what to say here? Serotonin is a happy hormone. So that means whenever you are in depression, like what to say, to come out of the anxiety and all, serotonin will help. Okay, the drug reserpine, what it will do? It decreases serotonin and it causes depression. So depressive drugs like reserpine. Okay, and antidepressant drug is like what to say? Serotonin. Serotonin levels lowered in depressive psychosis. Tryptophan availability, serotonin in brain induces sleep. That's the reason milk is in high quantities of tryptophan, and tryptophan involved in conversion of serotonin. So this way, before you going to the bed, if you are having a glass of milk, so it induces sleep because tryptophan is converting serotonin and serotonin induces sleep. And protein rich food like all amino acids plenty in blood, tryptophan couldn't enter into brain, serotonin less, that means alertness. What do you mean here? So all amino acids plenty in blood, tryptophan couldn't enter into brain, so there will be less serotonin production. Okay, carbohydrate rich food, insulin secretion, amino acids level in blood, lower tryptophan could enter into brain, more serotonin. So this way, so more protein food, there will be alertness, more carbohydrate food, there is allowing tryptophan into the brain and then production of serotonin, and it causes sleep. So now serotonin producing by 𝐸𝐺𝐼𝐻 cells of GIT, okay, or which is required for normal intestinal motility. So 𝐸𝐺𝐼𝐻 carcinoid tumors like small intestine, appendix, intermittent flushing, diarrhea. So what is 𝐸𝐺𝐼𝐻? So it is a carcinoid syndrome. High levels of serotonin are produced and degradation, and which is causing intermittent flushing and diarrhea. Tryptophan is diverted to serotonin, which leads to niacin. So here what is happening? More tryptophan will be in GIT, not entering into the other function like niacin production and all. So more tryptophan diverting to more serotonin, so more problematic things, so leads to pellagra and niacin deficiency, which is a characteristic feature of niacin deficiency is pellagra. Urine hydroxyindoletic acid excretion increase. So this high levels of hydroxyindoletic acid levels, you can make out there is a carcinoid tumors in the GIT. So to note down, melanin and melatonin are different. Melanin is produced from tyrosine, melatonin is coming from tryptophan. So melanin is a pigment of hair and skin, it is synthesized from tyrosine. Melatonin is a neurotransmitter synthesized from tryptophan. Melatonin is a pineal gland hormone and it is useful in circadian rhythm. Circadian rhythm means with this hormone synthesis only we could able to make the difference between daylight and the night. Melatonin, as I told you, it is a product of pineal gland. It blocks adrenocorticotropic hormones and steroid hormones secretions. So diurnal variations, for this difference you have need melatonin, and sleep wake cycles also regulated by melatonin. Biological rhythms also maintained, biological clock also maintained by melatonin. So we see here tryptophan degradation. So indoletic acid to indole, indole to indoxyl group, indoxyl sulfate and indican. So this is another alternative route where tryptophan is catabolized and then excreted into the urine. Hartnupp's disease. So what is Hartnupp's disease? So here it is a autosomal recessive disorder, Hartnupp's disease. What is happening here? If there is a defect in the transport of or absorption of tryptophan in the GIT tract, or also in reabsorption of renal tubules. So if there is any defect in these absorptive or transport mechanisms, it leads to no transport of tryptophan to intestinal cell for absorption and reabsorption of tryptophan in the renal kidney tubules. So tryptophan will simply excrete in the urine, or it will not be available for serotonin, melatonin and other important substance formation. So it leads to Hartnupp's. So there is no serotonin, there is no melatonin production if tryptophan is near. So these are the characteristic symptoms of Hartnupp's disease. So one more deficiency, that is niacin. So if tryptophan is not there in case of Hartnupp's disease, because Hartnupp's disease is the absence of tryptophan, because there is no carrier available to absorb the tryptophan in intestine as well as in the renal tubules for its reabsorption. So it leads to serotonin deficiency, it leads to melatonin deficiency, it leads to niacin deficiency. So it causes pellagra. So Hartnupp's disease person have characteristic symptoms such as pellagra. So what are the things? Dermatitis, ataxia, aminoaciduria. Treatment is high protein diet, and niacin also sometimes will correct the pellagra conditions. So when you see the overview of tryptophan metabolism, you see tryptophan converted into N-formylquinurinin, formal tetrahydrofolate, 1 carbon unit donor here, and quinurinin to thiohydroxyquinurinin, and alanine forms entering into gluconeogenic pathway, and anthralinic acid to form NADP pathway, and S2S ketogenic pathway. So that's why tryptophan is both glucogenic and ketogenic, and involved in serotonin production and melatonin production. The excreted product indican and 5-hydroxyindoletic acid, both are excretory products of tryptophan. So in cancerous conditions, in carcinoid tumors, this 5-hydroxyindoletic acid concentration will be high. With this you can make out 𝐸𝐺𝐼𝐻 or carcinoid tumors in GIT. So that's all about important substance coming from tryptophan and its related disorders. Thanks for watching. Thank you.